So, log identities. Make sure we know some basic log identities. Essentially, the log and exponent undo each other. So in this case, exponent x base log base a gives us x. This is a reverse form of that. The log and exponent undo each other. Okay, the log of any base of 1 is equal to 0, because this means when we actually convert this, this is actually a to the 0 equals 1. So it doesn't matter what base we use, we're always going to get 1 if 0 if our log argument is 1. If the base and the argument match, it's equal to 1, because really this is just a to the power 1 equals a. And we have this other property that these powers actually can, in a ratio, can reduce themselves. Okay, and the reason why, I'll just give you a brief explanation why. So we have log a to the power m and x to the power m, and let's say that's equal to b, okay, some exponent b. If I put it in an exponential form, it looks like this. Okay, and basically these powers, we can undo those powers with a root on both sides. So we end up with a to the b equals x, and then we can put that back into log form. Log a of x equals b. So these two expressions are equivalent to each other. Okay, so we should be able to prove some log identities, okay, using some log properties and using log properties to solve things, or in this case we're going to express as a single log, and we could probably solve this as well. Okay, so we're going to write this as log base a x plus 3 squared. Okay, because this is minus, we can use a divide here, x squared minus 1, and we can make this log base a 4. Okay, so we can, if we want to solve this, we can express this as a single log by moving this log over to the other side. We might as well solve this though, because this is an equation we can easily solve, and we can do this by dropping the logs. So we get x plus 3 squared over x squared minus 1 equals 4, and we can actually solve this equation. X squared plus 6x plus 9 is equal to 4x squared minus 4. So we end up with 0 is equal to 3x squared minus 6x minus 13. I don't think this is factorable, so we would solve this using quadratic formula. Okay, so there's our quadratic formula. We should maybe simplify this. Okay, this becomes 6 plus minus square root 36. This is going to be negative 39 times 4 is negative, that's going to be negative 136. Okay, or sorry, 156. So 36 plus 156 is going to be 192. Okay, and that's all over 6. We could probably find common factors in here. Okay, so this will be divisible by probably 16 is, I would think it's going to be divisible by 16. Okay, so they're going to end up with, what's that going to be? 16 times 12. Actually, that's divisible by 36, it looks like. Or maybe not. Okay, so let's divide that by 16. So I'm going to get my calculator here. Okay, so it's divisible by 16 and divisible by 4. So that's divisible by 64, isn't it? Okay, so we have common factor of 8. Okay, so we get 6 plus minus 8 root 3 all over 6, and we can simplify that fraction into, that's going to be 3 plus minus 4 root 3 over 3. Okay? So this one here, we can just express this as one log. We can simplify this expression. This is not an equation, so we can't solve this like the first one. So this one we need to combine this. We need a common base. So here the base is base A, here is base 4, but since we're dividing, really the only time we see divide is when we have change of base formula. Okay, so I'm going to use a change of base formula, and the nice thing about that is it changes it to the base that I want, base 4. Okay, so then I'm going to combine these together, end up with log. Okay, that's going to be in the numerator, x plus 6 in the numerator. That's going to be a negative power, so it becomes x squared in the denominator. Okay, so there's my log expression. Okay, so I've combined my logs there. Here, same thing, I need to make sure I have a common base, use log properties. So I'm going to combine these. The negative logs are divide. The positive logs are times, so positive logs are in the numerator. I'm going to have power of x in there. X to the power 2 is going to be in the denominator since it's negative. Here I'm going to have negative power on a denominator, so that really should end up in the numerator because that's going to be divide, divide, so that's really going to be times. So it's going to be x minus 3 squared. Okay, and then we can probably simplify this. So we get log base 4 x minus 3 squared all over x. Okay, so we should simplify when we can.